Hey everyone. We are continuing on with chords, secants, and tangents and their properties. So we have three different properties that you guys need to memorize. Um, the first one is where you have intersecting chords or secants inside the circle. So remember, a chord has endpoints on the circle and it's a segment, whereas a secant is a line passing through. Okay? So type 1 says we have intersecting chords inside the circle, right? Here's a chord and here's a chord. We can set them up to be proportional and say that A times B equals C times D. All right, and we use this when they're intersecting. So that's the key here. If they're intersecting, we use this property. Okay, so type 2 is where they're intersecting outside the circle. So this one's when they intersect outside. Okay, and we set up a proportional relationship and say that A times quantity A plus B equals C times quantity C plus D. Okay, and type 3 is where we have an intersecting secant and a tangent. So, or a chord and tangent. Okay, but one is inside the circle and one is not. And we get to say a squared equals b, the outside part, times quantity b plus c. Okay, so it is just a bunch of memorization and we'll apply the math. So I will do the right side and leave you guys the left side problems. It's just one page today. Number 2 says find the length of BD, right? And we know that it's 4 plus whatever 5x minus 1 ends up being. So obviously we need to find x, and we're going to apply type 1 here, intersecting chords. So we'll say 6 times 6 equals 4 times this quantity, 5x minus 1. Okay, so 36 equals 20x minus 4. Okay, I add 4 to both sides. And that gives me x equals 2. Okay, so obviously now I'm going to plug in my x to what I got for this portion of BD, right? And I'll say 5 times 2 minus 1 is 9. So BD equals 4 plus 9, 13. Okay, so that was number 2, not too difficult. Number 4, they step it up a notch with the math here, but the way we solve it is still the same, right? We have two intersecting chords, so I'll say 18 times 2x minus 5 equals 14 times 2x plus 1. Okay, 18 times 2 is 36. X minus 90 equals 28x plus 14. So I'll subtract 28x on both sides. That's 8x, and add 90 is 104. So let me get my calculator out. And 104 divided by 8 is 13. So plugging into TQ, right, that's just a portion of the chord. So that would be 2 times 13 plus 1. So TQ is 26 plus 1, 27. Okay, finally, something different. here we have NL, right? We're finding the length of NL, which is a secant, right? Because it continues outside the circle. And a portion of that secant is 13, and the other portion is x. Okay, so we have two secants, right? That is type 2. We use the formula a times a plus b equals c times c plus d. Okay, and a is the portion outside the circle. So I'm going to say 13 times 13 plus x equals the portion outside of the circle. 10 times 10 plus 42. Okay, so we'll simplify this. 13 times 13 is 169 plus 13x equals 100. Well, actually, let's simplify inside and then multiply by 10. 10 plus 42 is 52. And 52 times 10 is 520. Okay, so we're just going to subtract 169 from 520. Is 351. So 13x equals 351, and divide by 13. X equals 27. Okay, so if x is 27, and that is the portion inside the circle, I'm trying to find the whole portion. I'll add 27 plus 13, and L is 40. Okay, so that's not too bad yet. Okay, let's see if they make the math a little bit harder. So far, I feel like it's been pretty simple. We're finding x, y. So, or yz, not xy. Xy is given. Yz. So we are going to say the outside portion, 15, times the sum of the two, right? The whole secant, 15 plus x plus 1, x minus 1 equals 12 times 12 plus x minus 8, x plus 8. Okay. So I'll simplify what's within the parentheses first. This is x plus 15 minus 1 is 14. And 12 times 12 plus 8 is 20, so that's x plus 20. This should make the math easier. I don't know what 15 times 14 is. 15 times 14. That didn't work. 210. So 15x plus 210 equals 12x plus 240. And if I subtract 12x on both sides, I'll get 3x. And subtract 210 from 240, that leaves me with 30. So x is 10. And I'm trying to find this portion yz. If x is 10, yz is 10 minus 1. Yz is 9. Okay, number 10. All right, so finally we're given something different. Hopefully you guys can see that PM is a secant, where LM is tangent. So we're using type 3, and the formula is a squared equals b times b plus c. So a squared would relate to my tangent. So that would be 16 squared equals, okay, and b is my outside portion of the secant, 8 times 8 plus 5x minus 1. so similar to a type 2. 16 squared is 256. 8 minus 1 is 7, so I'll say 5x plus 7 is 40x. Oh, I forgot my x. 40x plus 56. Okay, so subtract 56 from 256. And I get x equals 5. And I'm trying to find Pn. So that's the portion inside of the circle, right? My secant, but just the portion inside the circle. So that's 5 times 5 minus 1. So Pn equals 24. Okay, so let's see number 12. This one looks a little bit more interesting. Now my a squared is the tangent. So 3x squared. I'll put it in parentheses. Equals the sum, well, it's 9 times the sum of 9 plus 16. And 9 plus 16 is 25. Okay, so that's 9x squared, if I'm squaring that whole term. 9 times 25, well, if I have 25 cents times 9, that's $2.25. So 225 divided by 9. So, equals 25. And that means x is, I take the square root, 5. Okay. Number 14. Which type is this? It almost looks like a tangent, but it's not. This one's 2 chords. So that's type 2. It's the outside portion 4 times the quantity of the sum of the 2. So 2 plus 4 is 6 equals the outside portion times the sum of the 2, x plus 5. Okay, so that's 24 equals x times x is x squared, and x times 5 is 5x. So we have a trinomial here, right? So this is x squared plus 5x minus 24 equals 0. I told you this would come back. I'll factor this. Factors of negative 24 that add up to 5. I'm thinking of 8 and 3. And it's a positive 5, so I'm going to make this a positive 8 minus 3. So that's it. X plus 8, x minus 3 equals 0. Okay, so I might have two solutions here. I'll set x plus 8 equal to 0, and that gives me x equals negative 8. And I'll set x minus 3 equal to 0, and that gives me x equals 3. Okay, so let's think about this. If x is a distance, right, I have a distance of negative 8 or a distance of 3. Only one of those makes sense. Okay, that's x equals 3. So my solution is 3. Right, we can't have a negative distance. Okay, number 16. I bet this one's going to be tricky too. So this is type 3, a secant and a tangent. So secant and a tangent. The tangent is squared. X plus 5 squared equals 12 times, well, 12 plus 15 is 27. All right, let's come over to the right here. X plus 5 squared is x plus 5 times x plus 5. Okay, x times x is x squared. X times 5, 5x. 5 times x, 5x. 5 times 5 is 25. So the left side of my equation simplifies to x squared plus 10x plus 25 equals 12 times 27. And I won't pretend to know what that is. Let's see, 12 times 27 is 324. Okay, so I am going to subtract 324 on both sides. So 25 minus 324 is 299. Okay, so this is x squared plus 10x minus 299 equals 0. And we'll factor this now. Okay, so this might be a little tricky. Negative 299. Okay, so I have no idea if I can drag this over. So 299 divided by 3. Nope. 299 divided by 18, 19, 20. 21? No. 299 divided by 23. Oh, that was times. Okay, so I found one. 13 and 23 actually does work out, right? Because 13 and 23, if we're subtracting, right, one of them has to be subtraction because it's a negative 299. It does equal positive 10. Okay, so x minus 13 and x plus 23 equals 0. That gives me x equals 13, x equals negative 23. Okay, and I'm solving for x. So I can't have a negative distance. The same thing applies here. X is 13. And we're done. You guys can go ahead and work on the left side problems. Okay, have a good night.